When performing characterization of grain structure in brass samples, the tendency of those grains to twin, or to split into separate regions, presents a significant challenge. Often the desired information is the size of the entire brass grain, despite the fact that almost all grains have split into twins, and in the TEM image take on different grayscale values. In the past, this original grain information has been obtained with techniques like EBSD, which are much more costly than typical TEM. With deep learning, MIPAR has been able to teach a model how to differentiate grain boundaries from twin boundaries to obtain an accurate characterization of twinned brass grains without the need for expensive EBSD or time-consuming manual analysis. We see in the training data here how we have specified grain boundaries and left twin boundaries as interior. Using this model as the core of a MIPAR recipe, we have achieved an automated solution to detecting true brass grains. We see all of this twinning here has been correctly grouped into a single grain. Once the grains have been identified, it's relatively straightforward to then measure their size and produce a report from the measurements. For users who need even greater accuracy, MIPAR also gives the ability to perform rapid corrections, like so. Simply take your pen, draw this boundary, erase this boundary, hit accept, and then MIPAR will post-process those corrections into clean grain boundaries. See here, this one was produced and this boundary was removed. Then the measurements can be easily rerun and a new report produced. And all these capabilities, detection, manual edits, and report generation, are also available when processing batches of images. In conclusion, MIPAR's innovative solution enables users to rapidly and accurately analyze grain size in samples of highly twinned brass without the need to resort to manual tracing or to expensive EBSD analysis.